Chapter 10, Carboxylic and its derivative. 10.2 Nomenclature of Carboxylics. At the end of the lesson, the students should be able to draw structures and name the carboxyl compounds according to the IUPAC nomenclature. The parent chain must be equals or less than 10 carbons. Give common names with parent chain equals or less than 5 carbons. Aliphatic carboxylic. General formula RCOOH. If R is an alkyl group or other substituent group, parent chain select the longest continuous carbon chain containing the carboxyl groups. So the parent chain must be the longest continuous carbon chain with the carboxyl groups. Named by substituting the ending A and E in the corresponding alkene with OIC acid. Number by starting with COH group as carbon 1 means that the carbon of COH as carbon 1. The other substituent groups are listed in alphabetical orders and their locations are indicated by the lowest possible numbers. General formula for carboxylic CnH2nO2 and start from 1 and beyond. We have molecular formula, structure formula, IUPAC name, and common names. So the first member, CH2O2, structure formula is HCOH, methanol acid. Common name is called formic acid. Molecular formula C2H4O2, CH3COH, ethanol acid, acetic acid. C2H6O2, CH3CH2COH, propanoic acid, propanoic acid. C4H8O2, CH3CH2CH2COH, butanoic acid, butyric acid. C5H10O2, CH3 bracket CH23, so means that the CH2 repeat 3 times, then COH. Pentanoic acid, common name valeric acid. CH12O2, CH3 CH2 4 times repeat, then COH, hexanoic acid. C8H16O2, CH3 CH2 6 times repeat, COH, octanoic acid. C10H20O2, CH3 bracket CH2 8 times repeat, COH, decanoic acid. Okay, look at the first example. Apply the rules given. You must select the longest continuous carbon chain with the COH inside. So the COH, the carbon must be carbon 1. So this is the parent chain here. So you have how many carbon? You must start numbering from the carbon of COH. So carbon 1, carbon 2, carbon 3, carbon 4. So the parent chain is called what? It's called butanoic acid. Then we have substituents at carbon 3, which is a methyl groups. So we have carbon 3, so 3 methyl butanoic acid. So we look at the second example. We apply the same methods also. We pick the longest continuous carbon chain with the COH. So this is the parent chain here. You must start numbering from the C, which belong to COH. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. So the parent chain is called what? It's called pentanoic acid. Then we have methyl at carbon 3, and then we have bromo at carbon 4. Okay, so when you want to arrange the substituents, you must follow the alphabetical orders. So bromo first, so 4 bromo, 3 methyl, pentanoic acid. Continue the following example. Pick the longest continuous carbon chain with COH. So this is the parent. So you start numbering from the C, which belongs to COH. So carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So here you got 6 carbons. The 6 carbons parent is called what? It's called hexanoic acid. Then we have substituent is carbon 5, which is a cyclopentyl. So 5 cyclopentyl hexanoic acid. We continue the last example here. So we have the longest continuous carbon chain. So this is the longest. Start numbering from the carbons of COH. 1, 2, 3, 4, 5, 6. So it's called hexane acid as a parent. Then you have substituents hydroxyl groups at carbon 5. So it's called 5-hydroxyl hexanoic acid. Look at the first example. The benzene ring is attached to CH2 COH. The CH2 COH is the parent chain, so it's called ethanoic acid because 2 carbon. The benzene ring as a substituent is called phenyl, so phenyl ethanoic acid is the active name. The common name is phenyl acetic acid. Look at the front example. The longest continuous carbon chain is 3 carbons. So start numbering from the carbon of COH. 1, 2, 3. So it's called propanoic acid as a parent. Then benzene ring as substituents is called phenyl attached to carbon 2. So here propanoic acid is the parent. Then we have phenyl at carbon 2. So 2-phenyl propanoic acid. Both of this example is aliphatic carboxylic. Why? Because the benzene ring is not directly attached to the benzene ring. So it's called aliphatic carboxylic acid. If aromatic carboxylic acid, the benzene ring must be directly attached to COH. Look at the front example. So here, this is the parent chain. So we have 5 carbons. So it's called pentanoic acid. Then we have 2 substituents, which is the methyl groups at carbon 2 and carbon 4. So 2,4-dimethyl pentanoic acid. If R is alkynyl groups, longest continuous carbon chain with the carboxyl groups given parent names. Name X alkynic acid, X position of double bonds. We look at the first example. We must start numbering from the COH to carbon 1. So you can see here, the COH is carbon 1 and the carbon bond at carbon 2. So here you can see you have 4 carbons, so it's called 2-butyric acid. Look at the second example. 1, 2, 3, 4, 5. So we have 5 carbons as a parent chain. So carboxylic acid have 5 carbons, and we have carbon bonds at carbon 3. So you can see here, trans 3-pentanoic acid. What is trans? Because here you can see it's transform. Transform. Okay. Then we look for the following example. We have 1, 2, 3 carbons here. You have COH at carbon 1 and carbon bond at carbon 2. So we have benzene ring as substituents at carbon 3. So here is called cis 3-phenyl 2-propanoic acid. So you can see it's cis form. Cis. Okay, if R is cycloalkyl groups, cyclic carboxylic acid, named cycloalkanecarboxylic acid, the carbon atoms bonded to COH group number as carbon 1. So COH is the parent. So you can see here, cyclopentane carboxylic acid. So it means that COH is the parent, it's the carboxylic acid. Then you have cyclopentane connect to COH, cyclopentane carboxylic acid. Then the second one, COH is the parent here, so it's called carboxylic acid. Then you have substituent carbon 3, cyclohexane carboxylic acid. Then you have substituent at carbon 3, so 3-ethyl cyclohexane carboxylic acid. Then you have here, the COH is the parent name also, carboxylic acid. So you have here, the substituent at carbon 3, then you have carbon bond at carbon 2. So 2-cyclopentane carboxylic acid. Then you have bromo at carbon 3, so 3-bromo 2-cyclopentane carboxylic acid.
Thank you for watching.